Okay, guys, welcome back. This is lesson 8, reading expressions in which letters stand for numbers. My target for today is I can read expressions in which letters stand for numbers, and I can identify parts of an algebraic expression using mathematical terms for all operations. So, what are we doing? So I'm going to, in this first group of examples, I'm going to write an expression using words for each of the expressions given. What does that mean? It's pretty simple. For letter A here, I have A minus B. So I could write this a number of different ways. Any of these are acceptable. I could write A minus B, or B subtracted from A. All right, for B, I have the expression xy. Remember when I have two variables next to each other, even though there's no symbol in between, that implies multiplication. All right, so this means x times y, or x multiplied by y, or we could say the product of x and y. So for D, this one I have an exponent. I have D minus B to the third power. So again, I'm just going to write an expression that describes what I see up here. D, oops, I spelled minus wrong. That's funny. D minus B raised to the third power. Okay? I could also say B to the third power subtracted from D. The difference of D and B raised to the third power. Okay? Any of those things would work. Lastly, I have 3 divided by D plus F. All right? You could write it exactly how you just said it. So if you just read the expression out loud, right? Because that's what we're doing today. We're reading the expressions. If you just read the expression out loud and write down what you read aloud, you'll get the correct answer. So if this is 3 divided by D plus F, I can say 3 divided by the quantity D plus F. Notice, however, I did include this term right here, the quantity, because if I just said 3 divided by D plus F, that could mean 3 divided by D plus F, which is different than what I have up here. These two expressions are different. That's why I included this term, the quantity, because it's showing that these two are together. All right, so if we go to the problem set for the day, let's take a look at this first group of questions. I'm going to do one or two with you. So for the first group of questions, it says circle all the vocabulary words that could be used to describe the given expression. Now I have 6x minus h. And then underneath it says addition, subtraction, multiplication, division. And I'm going to circle each of these words that could be used to describe what's happening up here. So let's take a look at this. 6h. Remember that implies, or that means 6 times h. Okay? And then minus 10. So let's go through and check. Do we see anything that could tell us that we're adding? Do we see any addition? No, I don't see any plus signs. Do we have subtraction? Yep, I have subtraction. Do we have multiplication? Well, remember, if you have a number next to a variable, that implies multiplication. So yes, we have multiplication. Do I have division? Do I see a division sign or a fraction? No. So there's no division. All right, let's take a look at number 3 here. 5 times 2 plus d minus 8. Remember, if I have a number next to parentheses like this, it means this number is being multiplied to both of the terms inside of the parentheses. So let's go through our list and check and see which of these words can be used to describe this expression. Do I have addition? I sure do. I'm going to circle addition. Do I have subtraction? Yes, I do. So I'm going to circle subtraction. Is anything or any of these terms being multiplied? Well, I got 5 times 2 plus 8. So yes, I have multiplication. And do I have division? Well, no, I don't see a division sign or a fraction. So no, I do not have division. All right, on the second page of our problem set, all right, I got some more up here, which are just like the ones in the front. And then if we come down here, we got this guy, this fun guy, number 11. Which expression is equivalent to 30 minus 7x minus 2? Well, what I have to do first is I have to combine my like terms. What does that mean? Well, 30 and 7x are not like terms because the 7 is being multiplied to an x. It's being multiplied to a variable, whereas 30 is not. So these are not like terms. Likewise, 7x and 2 are not like terms because there's no x next to the 2. However, 30 and negative 2 are like terms. And 30 minus 2 is equal to 28. So if I combine these two terms, I get 28. And then I'm going to just copy this middle term, negative 7x. Now let's take a look at our answers here. Do any of these answers match 28 minus 7x? No, 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 and no. Okay, that's because we're not done. Next, I have to look for a greatest common factor. All right, because I'm going to factor this expression. And when I factor this expression, it means I'm going to pull something out. And if I pull something out, I'm dividing both of these terms by the factor I'm pulling out. So what's a common factor between 7 and 28? 7, Mr. Marlowe. Great job, guys. So I'm going to pull out that 7. 28 divided by 7 is 4. 7x divided by 7 is just x. Okay, if that doesn't make sense, I'm going to say 7x divided by 7. Okay, 7 divided by 7 is 1. So I'm left with 1. I'm left with 1x. And I can just write 1x as x, which is how we got just the x. Okay? So, do any of these match 7 times 4 minus x? Right there. If you have any questions, comments, concerns, email me or let me know.